Hello, guys. Welcome back to Cheenta Statistics Department, and I'm here with an exciting problem from IIT JAM MS 2020. Problem 1. It's a problem from real analysis. Really tests your basics if you go deep into it. And as you know that we don't stop just at solving the problems, we go ahead and explore with food for thoughts and much more clarity and details to understand the problem to the fullest. So let's get started, guys. This problem make you understand about the limit of a sequence of real numbers. So xn is a sequence of real numbers such that limit n tends to infinity xn by n is equal to some limit, positive limit, L greater than 0, you can generalize it. So it's asking that what is the property of xn? How is the xn behaving? So understand one key idea is that you cannot individually understand the idea of xn entirely from the behavior of the limits. Why? Because xn, the limit gives a long-term behavior. Okay, so we will see that some of the properties will not hold because it goes too much into details about how the xn is behaving among each other, not in the long-term behavior. Okay, let's try to understand. So as you have seen, we have certain clues over here. The hints we have given on our website, I will share the website link with you. Is that a hint one? It shows that if xn was bounded, show that xn by n is equal to 0 by Sandwich theorem. So it's very easy. You can easily understand that. This is the following. Say if xn was bounded, it means modulus of xn is greater than, less than, equal to, and greater than equal to 0. This xn is bounded. And therefore, modulus of xn by n will be what? Less than equal to m by m is a real number and greater than equal to 0 by n by 0. Now by Sandwich theorem, if you take a limit n tends to infinity, you see that this goes to 0, this goes to 0, so therefore this must go to 0. But here we know that xn is not going to 0, it's going to some positive value. So therefore it cannot be bounded. Okay? Very easy. Let's move ahead to the unbounded case. Can xn be unbounded? Let's check it out. Xn, if you do by algebra of the limits, xn by n goes to some positive real number, L greater than 0. And n goes to infinity. We know that the sequence n equal to n. So xn by n times n, this sequence will go to by algebra of the limits. But by algebra of the limits, you understand that both the limits must exist. Okay, there's a bit of a problem, but still the result will hold. Okay, here I will show you the proof also that it's xn, right? So here this limit is equal to limit n tends to infinity. Actually assumes that both the limit exist, okay, but here one of the limit goes to infinity. So you can understand this limit n goes to infinity and L, this goes to L. So both together will go to infinity actually. But here therefore xn goes to infinity. So actually it's unbounded. Xn is unbounded. But how can you show it mathematically to the details? So let's show it. You will again use the definition of epsilon delta. The xn by n goes to L. That means it's this, right? That means it's less than epsilon for some n after certain n, after n greater than some epsilon. Let's take epsilon to be some real number, okay, some positive real number. For some n, that's the definition of the limit of xn, right? Xn by n, the limit existence. So this shows that xn by n is actually less than S plus epsilon and L minus epsilon. There's a very small number less than epsilon. So both of them are positive now. So what do we get? We get something interesting. We get that xn by n is less than epsilon. So xn, therefore we get epsilon, L plus epsilon to n greater than L minus epsilon into n. So this goes to infinity. This goes to infinity as n tends to infinity. So this must go to infinity. It's unbounded. It's actually the same proof. The proof of that previous element is this. So it's xn is unbounded. So option is B is one of the correct options. So it's MCQ option, so one single option correct. So you can just click it. But here we are not just understanding solve the problem. Okay, we'll understand other cases also, and how we can generalize it, and we'll understand the problem to the deepest of it. Understand the result, understand the idea. So we have got this xn is unbounded. Now let's check if it's a convergent sequence or not. So suppose xn is convergent over here. If xn is convergent, whatever the hint is given. The hint is given that xn is convergent, then show that xn by n is go to 0. Use the algebra of limits over here. Xn is convergent. Okay, let's go to L, and therefore xn goes to L and 1 by n goes to 0. So by algebra of the limits, xn by n by multiplying will go to L into 0, that is 0. But here it goes to something positive, something non-zero. So therefore it's also not possible. See, can xn be monotonically in a decreasing sequence? Okay. So now you can, as I will tell you, you can easily understand from here that xn is a monotonically decreasing sequence is a very hard thing, because understand that xn is actually telling about the long-term behavior. So how the xn are decreasing or increasing doesn't matter. Okay. In fact, if you there is a result of Boson-Bostrom theorem that suppose xn is monotonically decreasing and bounded below. If it's bounded below and monotonically decreasing, we have a really interesting result. You know what? That's it. If x is monotonically decreasing and bounded below, we have this interesting result. What is the interesting result? And bounded below. Let me give you an analogy. So there's a like floor over here, bounded below. That means there's a bound below you, and you're monotonically decreasing. Something is monotonically coming closer and closer, but it will not go beyond the floor. That means it will hit somewhere, right, in between, or maybe the floor. That's what monotonically bounded convergence sequence, monotone convergence theorem say. It same goes for the, it's increasing and there is a ceiling above. It goes for the upper, like increasing case also. So it tells that if there is a monotone sequence and it's bounded, then it must have a limit. Okay. So understand, if it was a monotonically decreasing and bounded below, it would have been convergent, and therefore it would have gone to the hint 3. This hint 2 wala case. Okay. So you can take some examples that if xn is equal to minus n, it can go to minus infinity, minus n squared, it will go to infinity, minus infinity. For minus n, it will go to minus 1, minus root n is equal to 0. So this is a very varied behavior of the sequence. So we need something more. So it's not a general statement. So we'll understand, we'll construct a sequence. So as I will tell you, xn is, this means that xn by n ka long-term behavior, this is they are seeing. Okay, they are like, yeah, so that means what? Even if we increase the sequence initially and then it decrease by the normal way. So let's take xn is equal to minus this. This is the sequence. It goes to minus 0.9. But what if we define xn is to be like this? Xn for n greater than 10 and n for n less than equal to 10 greater than equal to 1. That means it's increasing first and then decreasing. So what I'm using here, that we are contradicting with the fact that xn by n the long-term behavior information is given. Okay, so I'm using a long-term behavior information. That's why if I cut it in the middle and replace the initial few sequence with something else, it will be remaining the same. That's what exactly did here. We did a surgery over the sequence. That's it. That's a beautiful idea. Okay, simple, beautiful, cute idea. So let's see. We can use the same idea. Now I will give the video link over here, and let's see now what are the food for thoughts. It's very easy. So the food for thoughts, guys. Now my question is that we can do everything, many of the things, since it's going to a limit L, suppose positive. You can do it for limit negative. But my question is that, what if it goes to a limit 0? What can you tell about the sequence? Because you cannot tell anything about the sequence in general, because limit n tends to infinity. If you multiply by it, it will become 0 into xn, limit xn will sort of 0 into infinity format. Okay. So it's sort of not L'Hopital in that sense, but it will be, so it's your exercise to think about it. Find examples for different cases. Is everything possible? How can the xn behave? So explore that problem now, explore the food for thought, and mention in the comments, guys, what you thought about it. Mention in the comments of this post what you thought about it, guys. Let's make discussion. Let's do discussion about this problem. Let's don't stop at the problem itself. Let's explore the problem. Then only the beauty of the learning of the subject will come, guys. Okay. So all the best, guys, and stay tuned and stay blessed. And if you have not subscribed till this point, please do subscribe and share the ideas with your friends. Share the same thing with your friends, guys. It'll be super awesome, guys. So I will see you in the next video, guys, and I will see you the next problem, guys, with your ideas. So let us know, let us know your views, let us know your comments, and stay tuned and stay blessed. And bye, guys.